As we look to continue multiplying rational expressions, today we're going to have two different rational expressions, two different fractions, multiplied together. It's important to remember that we have to completely factor the top and the bottom, and then we can cancel any factors that are both in the top and the bottom. It doesn't matter if they're vertically or diagonally, we can cancel them either way. Well, on this first part, there's nothing in the top that cancels with anything in the bottom. So very simply, we're just going to multiply straight across. So I'm going to write multiply across. That gives us 10x squared over 21. In the same way, let's look at the second problem. There's nothing in the top that cancels with anything in the bottom because this x plus 5 only cancels with another x plus 5. And since there is no other x plus 5, it's just going to be 3x squared divided by 4 times x plus 5. Remember, you can only cancel things that are complete factors and completely alike. As we look at the bottom section, we're going to have to consider possibly factoring first and then canceling. So, I'm going to draw my two fraction bars, and I'm going to look at which of my four parts needs factoring and which doesn't. Let's start with the ones that don't need factoring. The 3, the 6x, and the 2x plus 1. Those don't need factoring. However, the 4x squared minus 1 is an example of the difference of two squares. The difference of two squares factors to conjugates, x plus 1 and 2x minus 1. Now that we've factored everything, we can easily cancel the things that are factors. The 3 and the 6 cancel to 2 and 1. That leaves us with an answer of 2x over 2x minus 1. Once again, the 2x and the 2x minus 1 don't cancel because the 2x minus 1 is connected together. Let's look at problem 4. Once again, I'm going to write my two fraction bars with a time sign in between and write down the parts that don't need to be canceled immediately. Now let's look at the easy things to factor. Can you think of how the bottom factors? Well, that's conjugates again, x plus 2, x minus 2. And the top, 8x plus 16, has a GCF of 8. 8 times x plus 2. Now we can cancel the x minus 1s. The x minus 2's, the x plus 2's, and the 8's. The only thing left in the top is a 1. The only thing left in the bottom, it seems, is an x. So my answer is 1 over x.